NFPA 70, the National Electrical Code, in Article 110.26. A1 states that electrical equipment shall not be installed in a hazardous classified location that is not suitable for its intended use. The area within 18 inches of a panel board is classified as a Class 1, Division 2, Group B hazardous location. This is due to the presence of flammable vapors that may be present during normal operation or maintenance. Electrical equipment installed in hazardous locations must be suitable for the classification of the location. If an air handler is not classified for use in a Class 1, Division 2, Group B hazardous location, it is not suitable. Based on the NEC, installing another circuit from a 208 volts panel with an air handler located less than 18 inches from the panel is against code. This is because the air handler is not suitable for use in the hazardous location created by the panel. The original installation of the air handler less than 18 inches from the panel was also a code violation. To correct the situation, the air handler must be relocated, or a barrier must be installed to separate it from the panel. Installing a new circuit from the panel must be performed by a qualified electrician who is familiar with the NEC requirements for hazardous locations. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for safe electrical installations. Adhering to these regulations is crucial for preventing electrical hazards and ensuring the safety of people and property. Article 110.26 addresses the essential concept of workspace around electrical equipment. It mandates that sufficient space must be maintained around electrical equipment to allow for safe operation and maintenance. This workspace ensures that electricians and other qualified personnel can access the equipment to perform tasks such as inspections, repairs, and upgrades without being exposed to unnecessary risks. Article 110.26. A1 specifically deals with the width of the workspace. It states that the width of the working space in front of electrical equipment shall be the width of the equipment, or 30 inches, whichever is greater. This requirement ensures that workers have enough lateral space to move around and perform their tasks safely. For example, if a panel board is 24 inches wide, the required workspace in front of it would be 30 inches. If the panel board is 36 inches wide, then the required workspace would be 36 inches. The height of the workspace, as covered in Article 110.26. A3 dictates that the workspace must extend from the grade, floor, or platform to a height of at least 6.5 feet, or the height of the equipment, whichever is greater. This vertical clearance ensures that workers can stand upright and move freely without hitting their heads on overhead obstructions. For equipment installed at a lower level, the 6.5 feet clearance still applies. Adequate lighting is crucial for safe electrical work. Article 110.26. D requires that sufficient illumination be provided in the workspace around electrical equipment. Proper lighting enables workers to clearly see what they are doing, reducing the risk of accidents and errors. The illumination level should be adequate for the specific tasks being performed. Article 110.27 covers the protection of electrical equipment. It states that electrical equipment likely to be exposed to physical damage must be suitably protected. This protection can be achieved through various means such as installing barriers, enclosures, or guards. The goal is to prevent accidental contact with energized parts and to protect the equipment from damage that could lead to electrical hazards. For instance, a panel board located in a busy warehouse might need a physical barrier to prevent it from being struck by forklifts or other machinery. Hazardous classified locations refer to areas where flammable gases, vapors, dust, or fibers may be present in the air in sufficient quantities to cause explosions or fires. These locations require special precautions to prevent ignition. Class 1 locations are those where flammable gases or vapors are, or may be, present in the air in quantities sufficient to produce explosive or ignitable mixtures. Division 2 locations are those where flammable gases or vapors are handled, processed, or used, but are normally confined within closed containers or closed systems from which they can escape only in case of accidental rupture or breakdown of such containers or systems, or in case of abnormal operation of equipment. Group B refers to atmospheres containing hydrogen, manufactured gas, or similar gases. Electrical equipment intended for use in hazardous locations must be specifically designed and tested to prevent ignition of the hazardous materials present. This equipment is typically explosion-proof or intrinsically safe. Explosion-proof equipment is designed to contain any explosion that may occur within the enclosure, preventing it from igniting the surrounding atmosphere. Intrinsically safe equipment operates at such lower energy levels that it cannot produce a spark or thermal effect capable of igniting the hazardous materials. Using equipment that is not rated for the specific hazardous location can have catastrophic consequences. An air handler installed within 18 inches of a panel board in a Class 1, Division 2, Group B hazardous location must be suitable for that classification. If the air handler is not designed and tested for use in such a hazardous environment, it poses a significant risk of ignition. The presence of an unrated air handler in a hazardous location can lead to several potential dangers. Firstly, the air handler's electrical components, such as motors, switches, and wiring, could generate sparks or heat that could ignite the flammable vapors present in the air. Secondly, the air handler's enclosure might not be able to contain an internal explosion, allowing the flames and pressure to propagate to the surrounding environment. Thirdly, the air handler's materials of construction might not be compatible with the hazardous materials, leading to corrosion or degradation that could compromise its safety functions. In addition to the immediate risk of explosion or fire, an unrated air handler in a hazardous location can also create long-term safety issues. The presence of the hazardous environment can accelerate the deterioration of the air handler's components, leading to malfunctions and increased maintenance requirements. The use of an unrated air handler can also invalidate the facility's insurance coverage and expose the owners and operators to legal liability in the event of an accident. To ensure safety, it is essential to use only equipment that is specifically designed and rated for the hazardous location in question. This equipment must be installed and maintained in accordance with the manufacturer's instructions and the applicable codes and standards. Regular inspections and testing should be performed to verify the equipment's continued suitability for the hazardous environment. When an existing installation is found to be in violation of the NEC, it is crucial to take corrective action promptly. In the case of an air handler located too close to a panel board in a hazardous location, there are two primary options. Firstly, relocate the air handler, or secondly, install a barrier. Relocating the air handler involves moving it to a location where it is no longer within the hazardous zone. This might require significant modifications to the building's layout and infrastructure, but it is the most effective way to eliminate the hazard. Before relocating the air handler, it is essential to carefully assess the new location to ensure that it meets all applicable codes and standards. The new location must have adequate ventilation, access for maintenance, and protection from physical damage. It is also important to consider the impact of the relocation on the air handler's performance and efficiency. Installing a barrier involves constructing a physical partition between the air handler and the panel board. The barrier must be made of fire-resistant materials and must be designed to prevent the spread of flammable vapors. The barrier should extend from the floor to the ceiling and should be sealed to prevent any gaps or openings. Before installing a barrier, it is essential to consult with a qualified engineer or electrician to ensure that the barrier is properly designed and installed. The barrier must be able to withstand the pressure of an explosion and must not create any new hazards, such as obstructing access to the panel board. In addition to relocating the air handler or installing a barrier, it is also important to address any other code violations that may be present. This might involve upgrading the electrical equipment, improving the ventilation system, or implementing additional safety measures. All corrected actions should be performed by qualified personnel in accordance with the applicable codes and standards. The National Electrical Code is a comprehensive set of standards and guidelines for safe electrical installations. It is updated every 3 years to reflect the latest advancements in technology and best practices. Staying up to date with the NEC is crucial for ensuring the safety of people and property. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It also includes specific requirements for hazardous locations. Familiarizing yourself with the NEC is essential for anyone involved in the design, installation, or maintenance of electrical systems. The NEC is available for purchase from the National Fire Protection Association and other sources. It is also available online through various subscription services. In addition to the NEC, there are other codes and standards that may be applicable to electrical installations. These include local built-in codes, state regulations, and industry-specific standards. It is important to be aware of all applicable codes and standards and to ensure that all electrical installations comply with these requirements. Working with electricity can be dangerous if not done properly. It is essential to take precautions to protect yourself and others from electrical hazards. Always de-energize electrical circuits before working on them. Use insulated tools and equipment. Wear appropriate personal protective equipment such as safety glasses and gloves. Never work on electrical equipment in wet or damp conditions. If you are not qualified to perform electrical work, hire a qualified electrician. Qualified electricians have the training and experience necessary to perform electrical work safely and correctly. They are also familiar with the NEC and other applicable codes and standards. Hiring a qualified electrician can help to ensure that your electrical system is safe and reliable. When selecting an electrician, it is important to check their credentials and references. Make sure that they are licensed and insured. Ask them about their experience with similar projects. Get a written estimate before work begins. Do not hesitate to ask questions about the electrician's qualifications, experience, and work practices. A qualified electrician will be happy to answer your questions and address any concerns you may have. By taking the necessary precautions and hiring a qualified electrician, you can help to ensure that your electrical system is safe and reliable. Remember that electrical safety is everyone's responsibility. The presence of flammable vapors necessitates adherence to specific safety protocols and the use of appropriately rated equipment to mitigate the risk of fire or explosion. The combination of a 208-volt electrical panel and a nearby air handler introduces a potential hazard that must be addressed in accordance with the National Electrical Code. The NEC provides guidelines for maintaining safe distances between electrical equipment and potential sources of flammable vapors to prevent ignition and ensure the safety of personnel and property. The location of an air handler within 18 inches of a 208-volt electrical panel raises concerns about compliance with the NEC requirements for hazardous location. This proximity may create a Class 1 Division 2 Group B hazardous location, where flammable vapors could be present under abnormal operating conditions. In such cases, the air handler must be rated for use in hazardous locations to prevent ignition of the flammable vapors. The NEC guidelines for hazardous locations are designed to minimize the risk of fire or explosion by ensuring that electrical equipment is suitable for the environment in which it is installed. Compliance with these guidelines is essential for maintaining a safe working environment and preventing accidents that could result in injuries or property damage. When evaluating the safety of an electrical installation, it's important to consider the potential sources of flammable vapors and the proximity of electrical equipment to those sources. In the case of an air handler near a 208-volt electrical panel, it's necessary to assess the likelihood of flammable vapors being present and to ensure that the air handler is rated for use in a hazardous location if necessary. The NEC requirements for hazardous locations may vary depending on the specific circumstances of the installation. It's important to consult the NEC and any applicable local codes to determine the appropriate safety measures for the specific situation. Failure to comply with these requirements could result in serious consequences, including fines, legal liabilities, and potential safety hazards. Therefore, it's crucial to prioritize safety and ensure that all electrical installations meet the NEC requirements for hazardous locations. A qualified electrician can assess the installation and determine whether it complies with the NEC requirements for hazardous locations. If the air handler is not rated for use in a hazardous location, the electrician may recommend relocating the air handler or installing a barrier to separate it from the electrical panel. The electrician can also provide guidance on selecting and installing equipment that is suitable for use in hazardous locations. Compliance with the NEC requirements for hazardous locations is essential for maintaining a safe working environment and preventing accidents that could result in injuries or property damage. The NEC is a comprehensive set of standards and guidelines for safe electrical installations. It is updated every 3 years to reflect the latest advancements in technology and best practices. Staying up to date with the NEC is crucial for ensuring the safety of people and property. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It also includes specific requirements for hazardous locations. Familiarizing yourself with the NEC is essential for anyone involved in the design, installation, or maintenance of electrical systems.